Ever wished your computer could read your mind and just do the thing? Microsoft's large action model is like the superhero your Windows PC didn't know it needed, except it wears a cape made of code. This AI doesn't just talk the talk, it walks the digital walk, diving into Word, Excel, and PowerPoint like a pro. Forget fumbling through menus. Large action model executes your commands so smoothly it's almost like magic. Finally, an AI that doesn't just suggest solutions, it gets off its virtual chair and does them. The purpose behind large action model. What if your AI could do more than just chat? Imagine an assistant that not only understands your commands but dives headfirst into action. Enter Microsoft's large action model, a revolutionary leap beyond traditional text-generating AI. Large action model doesn't just provide answers or instructions. It rolls up its virtual sleeves and gets the job done, navigating software interfaces like a seasoned pro. The genius of large action model lies in its ability to plan and execute tasks in real time. Need a file saved, text highlighted, or calculation completed? Large action model is on it, seamlessly interacting with applications to turn your commands into tangible results. This isn't your average AI, it's a game-changing powerhouse of productivity and efficiency. To achieve this marvel, Microsoft employed a trifecta of advanced training techniques: supervised fine-tuning for precision, imitation learning to mimic expert behavior, and reinforcement learning to adapt dynamically. Together, they transformed large action model into more than an assistant. It's an interactive partner, capable of managing complex workflows with finesse. Say goodbye to static AI and hello to a dynamic, action-driven ally that's redefining the boundaries of what technology can achieve. The foundation of training data. Every superhero has an origin story, and for Microsoft's large action model, it all begins with its training data. Picture a treasure chest filled with task descriptions, real action sequences, and step-by-step guides sourced from some of the most trusted places: official software documentation, WikiHow, and Bing search queries. Microsoft's team didn't just compile this data, they crafted it into actionable masterpieces using the brilliance of GPT-4. From simple tasks like changing fonts in Word to complex workflows like creating user-defined styles or multi-step formatting, large action model training dataset was designed to be as versatile as a Swiss Army knife. But the real magic happened with data evolving. An innovative approach where GPT-4 spiced up basic tasks by throwing in extra conditions or instructions. Imagine teaching a recipe and then adding a secret ingredient for that perfect twist. Large action models training was just as creative. With over 76,000 meticulously crafted task plan pairs, LAM emerged as a powerhouse, ready to tackle a universe of actions. This isn't just a data set. It's the brainpower behind a model that can think, plan, and execute like a true digital maestro. It's training with a purpose, setting the stage for an AI that's not just smart, but remarkably capable. Bridging text and actions. Turning written instructions into executable magic. Sounds like something out of a sci-fi movie, right? But that's exactly the challenge Microsoft tackled head-on. The result? A groundbreaking solution called Task Action Data. Think of it as a translator between human-like text instructions and real-world actions on your Windows interface. Picture this. You want to highlight some text in Word. Instead of fumbling around, the system knows exactly what to do. Click the Text Highlight Color button and perform the function as if it read your mind. By pairing every instruction, like select text, with its corresponding click or keyboard input, this innovation transformed vague plans into flawless execution. This meticulous pairing wasn't just about making things work, it was about making them work perfectly. Suddenly, large action model wasn't just generating clever ideas, it was acting on them with pinpoint precision. It's like giving your computer the power to not just read, but act on your commands, all while navigating the labyrinth of the Windows interface. It's seamless, it's smart, and it's redefining what's possible in the world of automation. The 4 phases of large action models development. LAM's journey to brilliance unfolded through a 4-phase training pipeline, each phase building on the last to supercharge its capabilities. It all began with Phase 1 coherent planning, where Mistel 7B, the base model, learned to craft detailed plans for tasks like inserting images or changing fonts in Word. Dubbed Large Action Model 1, it could map out steps but lacked the magic to execute them, a promising blueprint for what was to come. Enter Phase 2, Action Replication, where Microsoft armed Large Action Model with 2,192 examples from GPT-4, teaching it to mimic user actions like clicking menus or typing text. This leveled up Large Action Model 2 into a hands-on taskmaster. But why stop there? Phase 3. Self-discovery kicked in, challenging Large Action Model 2 to crack tasks that stumped GPT-4, resulting in 496 new success stories. Retraining with this data birthed Large Action Model 3, a sharper, problem-solving genius. Finally, Phase 4 reinforcement learning took center stage, where LAM 3 learned from its wins and losses through a reward model, emerging as Large Action Model 4, the pinnacle of precision, effortlessly applying every lesson to perfect its decisions. Large Action Model's evolution is a masterclass in turning plans into flawless execution. Real-world testing and performance. Microsoft put Large Action Model through its paces with real-world testing, blending offline simulations and live Windows environments to see how it handled 435 Word-related challenges. From opening blank documents to intricate formatting like inserting tables and pulling external data. The results? Stunning progress with each iteration. Large Action Model 1 started strong with a 35.6% success rate using textual instructions, but then LAM 2 soared to 76.8% by learning from GPT-4's examples. Large Action Model 3 added its own flair, reaching 79.3% by discovering solutions independently, and Large Action Model 4 capped it off with an impressive 81.2% success rate thanks to reinforcement learning. For perspective, GPT-4 in text-only mode hit 67.2%, and even with visual input, it managed just 75.5%, while the smaller GPT-4 Mini lagged at 62.3%. In live tests, LAM kept shining with a 71% success rate, completing tasks in just 30 to 42 seconds, outpacing GPT-4's 63%, which was slower and less precise. Large Action Model's performance showcases its brilliance in tackling tasks with speed and accuracy, proving it's a powerhouse in Windows environments. The role of the UFO agent. Imagine a futuristic assistant, one that doesn't just follow orders but truly understands your every digital need. Enter the UFO agent, Microsoft's innovative Windows-based marvel that's taking automation to the next level. UFO isn't your ordinary tool. It's a clever operator that interacts directly with graphical user interface elements, diving into the nitty-gritty details like control names, coordinates, and contextual cues. What's more, UFO serves as the eyes and ears for Large Action Model, passing along this treasure trove of data. Together, they form a dynamic duo, with Large Action Model making informed decisions about what action to take, be it selecting a menu item, typing out text, or executing a precise click. UFO doesn't stop there. It tracks completed steps in real time, ensuring every task flows seamlessly without a hitch. By merging real-time feedback with Large Action Model's powerful decision-making, UFO transforms mundane automation into a masterpiece of efficiency and intelligence. It's not just automation, it's automation with style, grace, and a futuristic twist that redefines what AI-driven workflows can achieve. Buckle up, UFO is setting new standards and taking us on a ride straight to the future. Broader implications and challenges. The development of Large Action Model signals a paradigm shift in AI's potential to act on instructions rather than merely generating text-based responses. Its ability to execute multi-step workflows across applications could revolutionize industries by automating repetitive tasks and enhancing productivity. However, this advancement also raises concerns about safety and accountability. An AI model capable of executing actions with minimal supervision must have robust error-checking mechanisms to prevent unintended consequences. Microsoft has emphasized the importance of requiring verification for certain steps and implementing safeguards to mitigate risks. Expanding large action model to other operating systems, such as macOS or mobile platforms, presents additional challenges. Each environment requires a unique dataset of labeled tasks and controls, a time-intensive process. Techniques like transfer learning or multitask learning may alleviate some of these challenges, but they remain areas of active research. And that's the magic of Microsoft's large action model, turning your every command into seamless action. If you're as excited as we are about the future of AI-powered productivity, don't just stop here. Hit that like button, subscribe for more tech breakthroughs, and share this with someone who needs a little large action model magic in their life. Let's stay connected as we explore the next big thing in tech together.